So for this problem, we had three people arguing about what the derivative was at this point here. And we had one person, I don't remember their names, but we had one person who felt that this was a horizontal line, so the slope would be 0. We had one person who felt that the line was vertical, and so the slope would be undefined. And then we had one person who felt that the slope was like somewhere in between, so -1. So here is the problem is you can kind of see a case for all of these, right? Because depending on like where you're looking, like if I'm just looking at this side, the slope is vertical, or it's approaching a vertical line. And if I'm just looking like here, the slope is horizontal on that side. So, and then I think this person is just kind of saying like an average of the two. But what we have here is a point of non-differentiability. So differentiability means the derivative exists, or the slope at that point exists. So is the function differentiable at this point? So we would say this is not a point of differentiability, okay? So we cannot find the derivative at this point. Now, a like common way to kind of explain it, an informal way, if you will, is like your curve isn't smooth. If your curve is smooth, like this one, this would be differentiable. But if you have something like where it's like, okay, the slope is here, it's approaching 0, and then all of a sudden it's something else, then your function is not differentiable at that point. So the more formal way of describing it is by describing limits from the left and the right. Okay, so if we look at from the left, so from the left, we can see that, I can't find my color again, doesn't matter. Okay, from the left, the slope is approaching a slope of 0. Okay, so this person was like half correct. They said the slope was 0. It is 0 on the left-hand side. So we would say the limit as x approaches this, we'll call this x equals a. The limit as x approaches a from the left-hand side, and we're not talking about the y coordinate, we're talking about the slope, right? We're saying the slope is 0. So how do we describe slope? F prime. So the limit as x approaches a on the left side of f prime does not equal, and then let's look at the right side. The right-hand limit is like approaching a really large positive number, right? So the limit as x approaches a on the positive side of f prime. So that's why this function is not differentiable at x equals a, because on the left-hand side, your slope is 0. On the right-hand slope, right-hand side, your slope is like something else entirely. So if your left-hand slope does not equal your right-hand slope, then the function is not differentiable at that point. Okay, so if the left-hand slope does not equal the right-hand slope, your function is not differentiable. Now, that's just one part of it. The first part of it, which I'm just going to go ahead and say now, even though I didn't cover it at the beginning, which I should have, is that f of x has to be continuous in the first place. So just to let you know, if you have, a jump discontinuity, you can't be differentiable at a point of discontinuity either. So if your function is not continuous, then your function is also not differentiable. So when you take your notes on differentiability, or if you've already taken your notes on differentiability, just pay attention to all like the different kinds of non-differentiability. Like if your slope is exactly vertical, that's an undefined slope, so that's not differentiable. If your function is not continuous, then it's not differentiable. Or if, like in this example, your function has a cusp. That's what we call this. We call this a cusp. So if you have a corner is like two lines meeting, or a cusp, which is like where a curve meets another curve, or like a curve meets a line. If you have like just a quick slope change, then and it's not a smooth curve. Smooth curve is differentiable, but in all of these different examples I've given you, it's not differentiable.